Well, welcome to this sort of tutorial on the ESP32 and a GT911 capacitive touchscreen. These are the sort of touch screens that you would typically get on a sort of a mobile phone or a sat nav, and they are available on places like AliExpress. So I'll just bring up the screen here. As you can see, they're very cheap. You can get them from sort of 4.5 inches up to I think about 11 inches in size. One of the great things about them, if you get the GT911 touch screens, is they are very simple to wire up, and you can use them basically as a control panel for multiple buttons just with the 6 connections. So this is a sort of a close-up of the screen. Not a lot to see. Obviously there's no LCD behind it. Some of these are mounted on LCDs, especially the more expensive sort of touch screens you can get. But to connect to them, this is the actual GT911 chip. It then goes through a ribbon cable and it connects to this connector. Now I've got a bigger version of this. It's an FPC 6P. I've got a link, so sort of a more of a description of this on the Digital Town website that goes with this video. But basically this little connector allows the ribbon cable to come in, and then obviously you've got your pins that go off to your ESP32 or your Arduino. Now, a word of warning on this: the GT911 chip, this thing, is a 3.3 volt chip. So if you stick 5 volts into it, you'll probably release the magic smoke from it and blow it up. So if you're using an ESP32 or an Arduino Due, you're going to have no problem using one of these. If you want to use an Arduino Uno, Nano or Mega, the sort of the more common Arduinos, they will connect to these, but you're going to need a logic level shifter to change your logic pins from 3.3 volts, from 5 volts, sorry, to 3.3 volts, and vice versa. So there is a little board that you can get that goes in there for a few quid that does that sort of thing, but be warned, if you do not use one of those, it's all going to end in tears. Right, for this tutorial, this is part of my sort of model railway control panel tutorial, and what we're actually aiming at doing is building a control panel like this. So what I've done here, this is powered by an Arduino Due. This was my prototype, and I mounted 2 touch screens because an Arduino Due can use wire 1 and normal wire. I was able to connect 2 screens with the same address. They're mounted over some smoked acrylic. The track plans are marked on the smoked acrylic, and then underneath the acrylic I mounted some NeoPixels, and I'm just going to show you a quick video now of how it actually worked in my prototype. So that's my prototype traverser in action. What was actually happening there was when I touch the over the touch screen, it actually connects to a DCC++ system, and the traverser is running as a DCC accessory. So that's the sort of level you can go to, but you could just use one of these to control, you know, an old-fashioned sort of analog system, sending your controls to your points as normal. There's a whole set of options, and the great thing about these, when I've built control panels in the past, the absolute disaster is suddenly you realize you need a new button or a switch, and you're in there increasing the rat's nest of wiring in the system. Whereas with this, literally you could just add another LED under here or change the diagram under here. One thing I will say, when it comes to mounting these, some of these, where this black surround is, some of them come with a self-adhesive tape some of them come with a sort of felt. It seems to vary from model to model. The first version I did that you saw in my prototype, as you can see, I stuck these down. Bad move. I messed up, and I wanted to change something underneath and I couldn't. Just for your information, you can actually put the tape on top of the touchscreen, and it doesn't seem to have any issues at all. It doesn't sort of set off false triggers on the screen. However, I wanted it all to look smart and all be underneath, so for my new version I'm actually building a surround that goes around this. In fact, as I'm doing this recording in my garage, I've got a CNC machine cutting out the surround as I speak, so it's actually going to be mounted in a surround so that I can remove it and change things underneath as I want. The near pixels, because they mount under the acrylic, obviously I can change those at will, but just be aware, you know, once you've stuck these things down, they do not come up easily. The glass is only about 1.5 millimeters thick, and if you try to pull them up once they're stuck, on the whole it's going to break. Anyway, let's get on with some coding. So we're going to look at 3 sketches today. The first sketch, I'm just getting a single touch point out. The second sketch will get 5 touch points, and then the third sketch will show you how to basically create some virtual buttons as if you were doing an application. So right at the beginning, I'm using an ESP32, so these are the pins that I'm using. As you can see, it's using sort of the wire library, and then 2 pins plus VCC and ground, and on the little black ribbon cable it will give you the list of pins, sort of the order they're in. So the only library is the wire library. Now, credit where credit's due, I did not write most of this script. A lot of this stuff I got it off the internet, and I wish I could find which site I'd got it off, because it's a great version because it doesn't need a library. So the guy who wrote this has written a number of functions. Now what I have done, just to make life easier for myself, I have put scan I2C in. This is a basic scanning function. Let's just find where it is in here. It's in a lot of examples, he says, scrolling through rapidly. There we go. So this is, it's not required for the sketch. I just put it in there because for me it's a useful way of checking that I've actually got a connection with the screen and it doesn't use up much space at all. There are then a whole set of functions that the original writer created. Now his original script worked great on the Arduino Due but failed on an ESP32 because actually there was a bug in his script, and it was here. I think in his original script he'd got 32 in there and it should have been 40. For some reason the buffer overrun didn't cause an issue on the sketches on the Arduino Due, but the ESP32 kicked up a right old stink. Anyway, I haven't messed around with his functions. What I'm going to do is show you how I've used them. So the first thing I did, originally I think there was a whole load of stuff in the setup. I created a function, GT911 setup, and in that, if you go to that particular function, basically what it does is, here we go, it goes through a whole list of things that are needed to initialize the touchscreen. You don't need to touch this, you don't need to do anything with it. All you will do is you will get a message at the end saying that the screen has initialized, or a repeating message that there is a failure. So if you get the message that it's initialized, all is well. Then what I've done is I've created a function called check for touchscreen, and all this does is it basically uses these functions that have been written and it checks for touch. Now the screen can deal with 5 touches, and I'll show you that in the next sketch. I wasn't really interested in that, I only needed a single touch, but I did it anyway. I've got one anyway for you. Now one of the things I've done, because I'm using this as a virtual button control panel, shall we say, I have got a debounce system in here, because obviously when someone touches the control panel, you either put debounce in here or you write it in some other place within your script. I prefer to have the debounce in this little section. It made life easier. And then all it does is, as you touch, and my debounce is on 0.25 of a second, it will print out the X and the Y position. So let's bring up the serial monitor. If I touch sort of top leftish, there we are, 2623, going down bottom right, you can see the sort of the range of this touch screen. It's very, very sensitive. If I'm going to just leave my finger on there now, and you can see the debounce, it's just touching the same position over and over. But yeah, just touching around, you can see you get your X and your Y position. Now that is the basics of how the touchscreen works. So what we're going to do now is look at getting 5 touches. So here we are in Sketch version 2, and the only changes are in this one function that I've written, check for touchscreen. Now the way this works is it first of all reads this function that was written, and what it's doing is it comes back with the number of touch points that have been touched. So this could be sort of 0 to 5. Obviously I'm only interested if it's greater than 0. If it hasn't been touched, who cares? So all I've done here, I have left the debounce in. Now if you were using this for sort of gesture capturing, you certainly don't want debounce in here. But if I don't put the debounce in, the numbers will go up the serial monitor so fast that you won't be able to see what I'm doing. So all I've done in this is, the first thing it's going to do is it's going to tell us the number of touches, and then what it's going to do is work through the array, and there are these 2 arrays that give the X and, sorry, there's a data structure here that gives the X and the Y data location, and I'm working through the number of touches and I'm going to print it out. So let's have a go at this. So 2 fingers, there are 2 touches, 3 fingers, there we go, 5 touches. So as you can see, obviously I've got to hold my fingers on here, but that's basically how it works. So if you wanted to do gesture capturing, what you would do is remove the debounce, and obviously you would start to do some very clever code to figure out what is going on with the touch positions in relation to whatever the screen is above. That's not something that's needed for sort of model railway control panels. Most of us who build model railways are happy plugging away with a single finger on the control panel. So what I'm going to do now is go to the 3rd sketch, which will show you how I've simulated some buttons. So this is version 3 of the sketch. Very little change has been made, so let's just go through the changes. What I've done is I've got an integer here, number of buttons, in my case 3, just so you can see what we're working with here. This is how crude it gets. I've got a piece of paper underneath, buttons A, B and C. I haven't got time to build anything flashy. Now thinking about what I'm doing here, if you could imagine, you could have 30 or 40 buttons under here simply by getting yourself just a printer, printing out a screen with all the different button types that you wanted, and literally you could build yourself a multi-button controller with a piece of old A4 and one of these screens, just with those 6 wires that you see in here. So that's how flexible this is. So what I've done, I've got buttons A, B and C. Let's get this one out of the way. So what I did, I touched on the screen. So button A, I've just pressed roughly there. You can see I've got 217331. I probably missed slightly or nudged the screen because it's not taped down. Originally when I was testing I had 191331. Button B, if I press on that you can see 397336, and button C 542342. Now you'll notice that the numbers in the array do not match the numbers that were pressed, and yet still the system knows that I've pressed the button. The reason for this is obviously if you just took the XY coordinate for the touchscreen and just use that exact point, someone would actually have to touch your screen within, I think it's 0.6 of, no, less than that, 0.2 of a millimeter. You're never going to be that accurate. So we've got the number of buttons 3. If you wanted to make this 30 buttons, that's fine. All you do is change this to 30 and you would add your 30 coordinates. Notice there is a comma after each set of coordinates except the last one. If you get that wrong and you're adding more, you're going to mess up the system and you're going to get a bug. So let's go back down to the main function, check for touchscreen. This time I've got it set so it's only going to get the first touch. Its serial prints out as before the X and the Y, and then what it does is it passes those values through to a function that I call process button. So process button, those values have been passed over as my X and my Y. I've got an integer Q that I've declared. Now my screen is 153 millimeters wide, and from far left to far right is approximately 1011 touch points, 6.6 touch points per millimeter. So what I do is I allow a 5 millimeter plus or minus box around the touch point. So that gives a touch error of 33. So if you can imagine, I've got a target that I'm aiming for and I'm allowing 5 millimeters around that. So your target would be, if you like, the center of your button, and I'm allowing 5 millimeters error around the edge, and I've found that works fine. But you might want to change that if you've got clumsier fingers, or you might want to make the number smaller if you're very accurate and using small fingers, small buttons. Anyway, moving on. So what we do is for Q equals 0, Q is smaller than the number of buttons, so we're going to work through the button array, and what I'm doing is I'm saying, right, is the X position, which is 0, is my X greater than the X position minus the error, and smaller than the X position plus the error? And again, do the same with the Y, and that means that I know that the touch is within a box. Now if it does fulfill that, it sends a value through to another function, button action Q, and this is where basically you would process what happened with each button. So if the first button in my array gets pressed, button A has been serial print, button A has been pressed, button 1 serial button B's been pressed, 2 button C's been pressed. This could go on for 30 buttons. It really doesn't matter, however many you want to put in there. If you think about some of those big 11-inch touch screens, you know, I was thinking, and you know, you could have some incredible systems, control panels built there with no more than a piece of A4 paper with everything printed on it, and you could change it or add things anytime you wanted with just some little changes in software. Now on the video I showed you earlier of my DCC control panel, in here what it actually does is it sends basically a DCC code to my DCC++ system, so it knows what to send out down the track, which then goes to my traverser. As you noticed on the control panel I'd built, I'd got all my turnouts or points depending which side of the ocean you live on, and again it was sending out all the appropriate DCC codes. On this new one that I'm building, it's a modular system, which I'll explain in some tutorials on the bigger project, but basically it means that I can build these control panels for a modular board, and I can send out all the codes for that board. I can mess the order of the display screens up, and everything's going to work fine. But if you're building a simple control panel, this is where, if you like, the business is done. If you wanted a control panel that turns lights on, this is where you'd send the signal to turn the lights on. It's as simple as that. You can then use your Arduino or ESP32. You could have sounds coming off here. Anything you want could be controlled off here just by using that touch screen. So I hope that has been useful to you. It's been a bit of a whistle-stop tour of this. There is a link on the Digital Town website that goes to some more information on this. As I've said before, all the pins and everything are in the code. What I would tend to do is move all the functions onto a separate tab in your sketch. If you don't know how to do that, you just click Add Tab, and you can just move things out of the way so you don't corrupt them. But I hope that's been useful to you, and if it has, please click the like and subscribe. Bye for now, and if you're interested in the model railway control panels, I'll do a bigger project write-up as I get more done. Bye for now.